In this video, I'm going to share some tips for basic variance analysis related to some complications you can run into for direct materials. So a scenario overall is we produce different chemical compounds, and we're going to focus on one called Fluidex, and they go ahead and give us in our table up here the standard information for all our variable elements of manufacturing, direct materials, direct labor, and variable overhead. We're going to focus on the month of November, and here in our bullet points they give us various actual information. Now I have other videos that I think do a good job to help you out with labor and overhead. But within those different videos, we didn't run into a complication that we a lot of times run into in the real world with materials. So I'm just going to focus on that in this particular video with the materials. Because of that, I'm just going to isolate those bullet points that relate anything to do with material. Now recall, these are the formulas that are already provided and available in your book for the materials price variance and the material quantity variance. As you go through here, you might think, well, build up confidence. This seems very familiar. What's the complication? So our material price variance is actual quantity of material times the difference between actual price minus standard price. Well, right away we're going to run into a problem. The problem is we get two different quantities. They tell us that the amount purchased is 12,000 ounces. But they also tell us that unlike our other scenarios, we end up having some inventory on hand at the end of the month, and that's 2,500 ounces. Because of that, the amount we purchased is not the same as we used. If that occurs, the materials price variance is always going to use the actual quantity purchased. I don't care how much we used, I care about how much we bought, and that's going to be 12,000 ounces. The next thing that we need for the price variance is the actual price. Well, we're going to take the fact that point A tells us the total cost of materials was 225,000 divided by 12,000 ounces purchased is $18.75 per ounce. The last thing that we need for the materials price variance is the standard price, and I'm going to go back up here to the standard table. Now one trick I already talked about in another video is don't confuse yourself with what price or cost to use. We want the cost per unit for the material, and that's $20 per ounce. We don't care that there's $50 of material cost in a final Fluidex. So just ignore this right-hand column listed under standard cost. We care what the material costs per ounce. So that's what we're going to list, $20 per ounce. Actual quantity of 12,000 ounces times the difference between $18.75 actually paid per ounce minus $20 per ounce of what the standard. So before I do the final solution, consider that we're saving $1.25 per ounce. So this is going to be favorable. $1.25 per ounce saved times 12,000 ounces is $15,000 favorable. Here's where things get tricky. So when we jump to materials quantity variance, again, the formula looks just the same as what I shared in the past. Standard price times the difference between actual quantity minus standard quantity. Standard price is still $20 per ounce. You may say, well, what's so tricky about this? I'm just going to use the actual quantity purchase of 12,000. Well, here's the problem. We need to use the actual quantity used. And you may say, well, you didn't talk about that in past problems. Well, I didn't talk about it because the amount purchased was the same as the amount used, which is unrealistic in most companies. So we want to pull the actual quantity used. How do I figure that out? If I didn't start with any inventory, I bought 12,000 ounces, and I subtract out the amount of inventory we had on hand, 2,500, we back into the fact that we must have used 9,500 ounces. So that's what we want to use for the material quantity variance, the amount used, not the amount purchased. The only additional thing that I need is the standard quantity, which hasn't been calculated for us. To get that, we're going to take the total number of Fluidexes that were produced. Hopefully I'm pronouncing that item right. 3,750 times the standard of what we thought we would have needed for each Fluidux, which is 2.5 ounces. 2.5 times 3,750 is 9,375 ounces. So $20 per ounce standard times the difference between 9,500 ounces actually used minus 9,375 is what we anticipated. In this scenario, we used 125 more ounces than we anticipated, times $20 per ounce is $2,500 unfavorable. That's the additional complication if the amount purchased is different than the amount used. Actual quantity for price variance is quantity purchased. Actual quantity for quantity variance is quantity used. And I just want to point out, maybe this is a scenario where we bought much cheaper material for this Fluidux and it caused us to use a little bit more, but in the long run, we were able to get a much higher price variance than our quantity variance and saved us in the long run. Don't know, but that could be a reason why. Now, you need to work through the labor and overhead variances, but we're going to calculate those the same. We don't have the additional complication for those, so I'm going to let you do that on your own.